Namaste, welcome to Sitapragna channel. You are watching Apache Spark Masterclass Beginners course, and we are in chapter 3, and the entire chapter 3 is dedicated to getting started or creating our first app in different ways. And this is episode 2. I hope you enjoyed episode 1, and I hope you did the class work as well as homework. If you haven't done that, I highly recommend you to do that because we will be slowly building on these. Imagine these as steps. If you don't do step, if you don't, if you don't climb step 1 2 3, can you climb step 4? It will be hard. So imagine this is a staircase, one step at a time, one step at a time. Let's not try to jump. Let's go that. So do the classwork and homework. The URLs for classwork homework are provided in the description of each video. Go there, do those, and then come back here. Okay. Now, officially welcome back to this series. Did you ever wonder how to get started with PySpark? In the sense like how to upload your first data set and do something cool with that data. Well, let's check that out in this particular video, how to do that. Because I'm going to walk you through the steps you should try in your PySpark environment after, of course, it is up and running, like how to upload data, creating data frames, and remember we have estimated the value of pi. Let's do that one more time here. Okay. Whether you are on your laptop or whether you are using Docker, Databricks, doesn't matter. You can use all of them, and we have showed you how to install them in our chapter 2. The tips that I'm going to show you in this video will help you how to get started. So let's jump in, shall we? Before we start anything, we would need some data if we have to upload it, correct? If you are using a local setup or Docker, you can upload files directly into your Jupyter Notebook environment. And if you are using Databricks, you will upload files using Databricks file upload tool. And if you are using GitHub Codespace, you can just push your file to GitHub. I am going to use Zeppelin for this particular use case. So let's create a super simple CSV file, which is called movies.csv. And that file should contain data like this. Okay, this is my new, oops. Okay, it should contain movie, comma, year. Movie is The Godfather. And year 1972. And another film is Shawshank Redemption. Both are my favorite movies. If you haven't watched it, go ahead and watch them. 1994. And Pulp Fiction. I heard this is a great movie, but I never watched it. All right. Let's save it as movies.csv, and I'm putting it in my. Actually, you know what? Let me create a directory here, and let's name it data. And let me create another directory here, and let's call chapter 3, and let's create another directory here, and let's say episode 2. Okay, let's save this. Got it? Simple file. And I'm using Zeppelin, so I am going to go to Zeppelin. Do I have it? Yeah, I have it here. And let's try to. I don't use Zeppelin usually, so I'm just figuring it out. Figuring out how to import data. Maybe I cannot. Once you create that file, let's go ahead and let's create a new note, and I'm going to call this chapter 3 episode 2, since that is our episode. Okay, I'm not creating any folder. I guess let's create the folders. Okay, let's call it chapter 3, and I will still put it chapter 3 episode 2 here. So let's create that. Now what are we going to do here? We are going to read this CSV file. That is our goal, and I'm doing it through Zeppelin. Right, we will run a few lines of code to read the file and display its contents, and don't worry about how I am writing and etc. The point of these exercises in this entire chapter is to show you how you can write very easily a Spark application. What we are writing, what is happening, don't worry about it. We'll learn each thing that I'm doing, each line of code I'm writing in later chapters. This chapter is dedicated to show you how simply we can write Spark applications. Okay, but I'm just showing you different setups. In previous episode, I have shown you how to create a dummy RDD and print it. Now I'm showing you how to read, how easily we can read a CSV file. From PySpark, SQL, import Spark session. And once you create that Spark session, we are going to use the builder. Again, this is common if you remember. Get or create. I'm not giving the application name. It's optional. As I said, you can give it if you want. And let's create a data frame and let's call it spark.read. And you can say format and you can say CSV. That's one way to do it. Or you can directly give CSV here. Both will work. And then you are going to give the path of your movies file wherever it is. So let me go here. And I think it's in data. Chapter 3, chapter 2, here we go. So let me properties, copy it. Okay. So how are you going to read it from Zeppelin though? So you need to give file colon // then copy paste yours. Okay. You have 3 slashes. That is fine. That's how it should be. Got it? This will read the file, but again, oh, I didn't give the file name movies.csv and then give a comma after double quotes of, and then you are going to tell it has a header, right? My first line is what? Header, the column names. And how is data separated? Even though we are saying CSV, sometimes the data is not separated with commas. In general, we use any file that has a delimiter as a CSV. You can store it. It can be a comma, tab, a pipe symbol, anything you want. Then let's show it. Again, by the way, show is an action, just like collect. As soon as Spark sees show, it executes all the transformations that you have. Let's run it. Okay, never mind. From PySpark, what is it complaining? Expected semicolon expected, but dot found. Why can't we do? Is there something wrong with this? Interesting. Maybe it's Zeppelin, or actually, you know what? Maybe not. Maybe I need to tell it PySpark. Maybe it is thinking it's Spark, Python. I don't know, or Scala. Maybe it is thinking. Anyways, now we got this. You can see that, but do you see something weird here? It's not giving me my complete data. And what is the command that you need to use when showing that to see this data? Yes, you are right. False. Or you can say truncate false. So it is truncating and I don't want it to. So what happened now? No, I don't think you need to do this. Okay, that's fine. I guess we need to give truncate equals to false. Okay, I guess it is being too specific. So in Zeppelin, if you give by default false, it's not taking it. In Spark Shell, I guess somewhere it did. And remember the capital F for Python, you need to give capital F false. If it is Scala, you need to give just false. Okay, so for example, if I have to write the same code in Scala, how would you write it? For Scala, let's try it without the interpreter. I guess it will work. So you are going to import arg.apache.spark.sql.spark session. And then you are going to create the Spark session, Spark session dot builder dot get or create. Okay. Then you are going to create the data frame spark dot read dot CSV. You can actually copy paste this one as it is. But instead of separator equals to this, what you are going to do is uh, yeah. So instead of this for Scala, reading is fine. And then you are going to say option header. And what did I say? For Scala, you don't give capital T's, capital F's, true and false. It's small lowercase. And then again option. And you will tell separator as comma. Okay. Now the final one is the truncating. What I want to show is here you don't need to mention truncate equals to. By default, if you give false and small f, it will take it. Let's run this one. Okay, what is this complaining about? Value option is not a member of data frame. What option? Okay, I guess. Oh, sorry, never mind. Oh, where is this? Yeah, here we go. What is its problem? I guess there should be an order. Okay, for Scala, the order matters. So Spark read, then give the option of header, whether you have header or not, separator, and then the CSV. So it read the file. So here, what I wanted to show is, you see, this is small f in Python, capital F, and you need to mention truncate equals to. Here you don't have to mention it. That's what it is. And you can see the result is same in both the cases, right? And if I have to explain this again, first line, import Spark session from PySpark here. This is the entry point for working with data frames. Then we created Spark session. Think of this as the main Spark app running in the background. Next, we use Spark read CSV to load the movie's CSV file as a data frame. Then we set header equals to 2. So PySpark treats the first line as column names and then separator equals to because it's a comma separated file. Finally, df.show prints out the data frame in a nice tabular format right in your notebook. And just like that, you have read a CSV into PySpark and displayed the data. It's easy, right? Very easy. Now let's go ahead and calculate Py with PySpark. right? Something for fun. We need to do that. Let's use PySpark to estimate the value of pi. This is a classic distributed computing example, and it shows off PySpark's power for big calculations. Here's the code that we are going to create and run. I'm not going to type it. Here is the code. What are we doing here? We are importing and creating a Spark context. Remember, Spark context you will use for data RDDs in the old fashion. And this will again fail because we already have a session here. So what we need to do is whatever we did previously, we don't need this anymore. Uh, Spark dot, what was it? Spark context dot. We don't need to do get or create. It will get it. That's fine, I guess. Let's see. And then we imported the random module, which helps us generate random numbers. And then we set num samples, which is just a variable, to how much is this? A million. That's let's, you know what? This is a million, but let's put two more, which is 100 million. This is a very big number, but PySpark can handle it. Let's hope it can handle it on my system. Uh, depending on mine, that's fine. And we define a function called inside, which randomly picks a point x comma y using our random and checks if it's inside the unit circle or not. We then use Spark parallelize to spread the task across the cluster. For each point, we check if it's inside the circle using our inside function. The result is the total count of points that fall inside the circle. Finally, we estimate pi using the formula and print it out. By the way, this is the classic Monte Carlo pi estimation algorithm. Based on that, this was created. So let's run it. Let's hope it runs. Of course, it doesn't. It's complaining about the SC. What did we miss? We missed big time PySpark. The computer might be thinking, seriously, bro, 100 million? But yeah, as you can see, it ran fast. That's the power of PySpark. Pretty neat, right? This is the kind of large scale computation that PySpark makes possible even on your laptop. That's the amazing part of it, isn't it? So what did we do so far? We created and uploaded CSV file. Then we read the file into PySpark and displayed the data as a data frame. And then we ran a classic big data experiment estimating pi using PySpark. Let's dive into creating another Spark application, but let's use Scala this time. And I am going to walk you through every step you need to get started. And if you are curious about building robust data engineering pipelines with Spark, or if you just want to understand how Spark manages your data behind the scenes, let's check that out. Let's reiterate something. What is a Spark application? Sthita Pragnas? In the world of data engineering, you will often hear about Spark applications, many times actually, if you are a Spark developer. In simple terms, Spark application is your data pipeline, the code you write using Spark's APIs to process, transform, and analyze data. But no matter which API you use, everything starts with a Sthita Pragnas Spark session. The Spark session is the heart of any Spark application in Scala. Think of it as your entry pass to everything Spark has to offer. Now in Scala, we use something called an object to ensure there's only one instance of Spark session running. That's because every Spark application should have just one Spark context, like whatever we are doing here, right? Since we already have it, we are just reusing it from Spark. Let's look at some basic structure of Spark application in Scala. Shall we? All right, let's start with this one. So I'm going to just copy and paste it here. What are we doing here? We are defining or we are importing key Spark libraries. You will see data frame, right? And then we are importing Spark session. And actually, I forgot to import a couple of things. Those are and Spark session, of course, Spark session. We cannot forget that. And then we are also importing functions, different functions here. And then we are creating an object called first Spark application that extends app. This is Scala's way to make your code executable as a standalone application. Now inside this application, actually, I don't know why I'm writing that. I can write it here, but whenever there is Scala, I prefer to do it from here. So let's go ahead, right click, new, just call a file and let's name this, uh, what was it? Let's put it here. And inside this application object, we need to actually create the Spark session, right? How do you do that? By writing something like this. We have, what are we doing here? We have the session, Spark session builder, which starts the creation process. Then we have master local one. This tells Spark to run locally with one thread, great for testing on your laptop. And then the app name we are giving Spark Playground. This is just the name for your Spark application, super helpful when monitoring jobs later. And get or create creates the session or retrieves it if it already exists. And then you are doing import Spark implicits, which brings in a bunch of useful functions for working with data frames. Got it? At this point, you have a working Spark application set up and ready to process data. So you can use this setup for any application that you want to write later on. Now let's get our hands dirty and actually read some data. Suppose you have Parquet files stored somewhere. Let's load them as a data frame. Got it? So this is the data. This is the code I'm going to use for that. Yeah. And by the way, you can actually have this in one line as well. That's fine. So what am I doing here? Source storage location. This is just a string with the path to our data, which I'm going to give in a minute. And then Spark read format, and we are going to tell Parquet. Previously, we have read CSV. You can use this method as well to load the CSV file and load. Then let's give us the source storage location, right? The result is stored in a data frame, which you can see. This is a data frame you can now work with. All right. So I just downloaded a file. Let me paste it here. The location, not the file. Um, let's copy this. I would need this one. And it's going to be that Titanic Parquet. It's going to, this Parquet file has the passengers list of Titanic. Now before running, you know the drill. Let me go. Let's see if let's figure out a way to add this to this. I'm not a big user of uh, this. I don't write my applications in Scala, just so you know. I use Glue. Current file, clear it. Oh, never mind. I'm like, why is it not giving me this? The reason is I haven't told it what it is. Okay, now it's good. Run with parameters, VM options, apply, run. I mean, I'm missing something, isn't it? Yeah, this bracket I am missing it. That's what. So I can go ahead. Okay. I mean, this is not the end of it because we are not printing the data frame. But I just want to run it to show you that it runs without any problems. And we actually created it. It won't print anything because I'm not displaying the data, but it runs. This is our application, correct? So far, when you run this, Spark creates a job with a single stage, why single stage? Which you can see visualized in the Spark UI. We are not going into Spark UI at this stage. Uh, all we have done here is read the data, but let's go a step further. What is it? What if you want to know how many records are in your data frame? That's where the count function comes in. So we are going to run that. Print ln, we have the data frame, and then you are going to say, give me the count. Df.count, it counts all the records in the data frame. Println just prints that count to your console. But under the hood, Spark does a lot more. This triggers what's called a directed acyclic graph, or in short, DAG in Spark. You will see in the Spark UI that the count function actually creates multiple stages. And somewhere it printed the count, and that is 891. And what is handy here? Spark Web UI. If I double click on this, it won't show anything because it already stopped it. While running the application, you can go ahead and see it, but it's already stopped it. That's why it's not displaying here. Yeah, you can look at the Spark history server right here on 4040. It's showing nothing. Maybe it's not for this one. The uptime is this much, but it is showing PySpark shell. This is for the PySpark shell that we have triggered. It's not for the Scala one. Scala one got triggered at 4043. So let's try at localhost. Does it, will it display? Yeah, it's still the Spark session. Doesn't matter. So that's why if you see this got triggered at 4043, not on 4040. It tried to do that. Somewhere here it will show you. It tried these three ports, but it didn't. So I'm assuming 4040 is the PySpark shell. 4041 is Spark shell. Which job did it run? The list tables, list databases, the Scala one. This is for the Scala one. And this might be for the Zeppelin. Spark shared process. I'm assuming, let's look at the application names and we can, yeah, Zeppelin. So you might be asking, why can you see the jobs of these, but not the one that we ran? Well, these are long lived. For example, my Zeppelin session is still on. My Spark shell is still on. My PySpark Spark session is still on. But my IntelliJ session is not on. It was on when it was running, but as it finished running the application, as you can see, it stopped it. That's why you are unable to find it on 4043. Got it? I mean, for these reasons, what you can do is you can maintain a Spark history server and have those all there. But that is a another story which I am not going to cover right now. But for the sake of this going to the UI, let's go ahead here and put the code here. And Scala, you don't need to give the interpreter. That's fine. And this is file. So let's give that. Okay, since we created it an application, it is not printing the data here. So let's not do that. Okay, it displayed you 891, but the point I am trying to make is this. So let me refresh this. It should show you what time is it? It is okay, where is my clock? Okay, right here. 46, which is this one. Okay. And these are jobs. It created 3 jobs for what? And why is it not giving proper names? Anyways, the point I want try to make here is that um, you can see on SparkUI a couple of things. We are going to cover all this in later videos. But I want to show you have something called stages. One stage performs local count on each executor. That's where your data lives, split it into partitions. So you can see all those details here. And once those are done, another stage shuffles the results, and whatever I'm talking about, you can see that not here. There should be not here either. Yeah, here DAG visualization you can see here, right? But what I'm trying to see is how this Zeppelin is executing it. I don't know why is it counts saying stage IDs. I am assuming that it's treating the entire all the cells code as a single job with different stages. I think that's what it is doing. That's why you are seeing all these things. Anyways, um, here you will have shuffle that happens. You can see that shuffle, right? Why? Because you are doing a count, and when you are trying to do a count, it needs the data from all the partitions, not just one partition, right? So that's where a shuffle happens. So another stage shuffles the results, so Spark can aggregate them into a final total count, which is what you can see under shuffle read. Got it? Every stage must finish all its tasks before moving on to the next. Spark handles retries for fault tolerance, but if a task fails repeatedly, the whole stage fails. Now, let's me give you a brief example of how a Spark, how a shuffle works. What is a shuffle? Which is very important, and this is costly as part of Spark computing power. Shuffle is costly, and you will definitely get an interview question on shuffling. Whenever Spark has to move data between executors, and you can see the executors, number of executors right here. Okay, how many executors? We only have one executor here, and it is up because it started when my Zeppelin started, and you can see. Since this is on my local machine, I only have one executor, but in your at your work, you will have a cluster, which means more than one executor, right? So, like during a count or group by, join or aggregation, all wide transformations, they create a shuffle. It's called wide transformation because it needs to access data spread out across the cluster. For example, if you have a column called groups with values like A, B, C, X, Y, Z, by default, Spark splits data into 200 partitions unless and until you repartition them into the number you like. It's always 200. Regardless of what values you have. But let's say you want to repartition your data frame so all records with the same group value go together. Now, when you try to do this, this will trigger a shuffle because first of all, it needs to know where your ABCs, XYZs are. What if on 2 different partitions you have A and A? It needs to know that so that they can group it together. That's why shuffles are expensive because they involve lots of data movement and sorting. So while they are sometimes necessary, like for joins or rebalancing your data, you want to avoid them unless you really need them, especially in production pipelines. Got it? And don't worry about all this. We have dedicated section to cover each and everything. I just wanted to show you, you know, how you can figure out how shuffle happens. Okay. And I am assuming these are our jobs, right? You can click on it. So this is the load that happened, that it read the Spark Parquet file, and you can see there is no shuffle to read it, just a map. And then you can see it scanned that and still no shuffle because it has, oh, sorry, there is shuffle. This is where it tried that count and looks like it skipped this particular stage for whatever reason. I'm assuming it's the print command that printed whatever count we have done. You can look at all the details here, but let's not go into all this. Just learn that when you did a count, a shuffle happened. So let's recap what we learned in this video. We learned how to set up a Spark application in Scala, starting with the Spark session, and how Spark splits work into stages and why that matters for performance, and what shuffling is, why it happens, and when to be careful. If you're just getting started, try running this sample code yourself and experiment with reading, counting, and repartitioning data. And if you want to dive deeper into group by joins and aggregations, stick around because we are going to do that in later chapters. We will cover those. Don't worry about that in upcoming videos. And if you found this helpful, give it a like, subscribe, and drop your questions or ideas for future topics in the comment section. Thanks for watching and happy coding with Spark. Happy sparking. See you in the next video. Peace out. Love you all.